Krakatoa, an exploding island, creating 120-foot tsunamis, drowning its victims for hundreds of miles. Vesuvius, incinerating the inhabitants of Pompeii with superheated clouds of ash and steam, entombing them in rock for 1,800 years. Mount St. Helens, obliterating everything in its path, trees, houses, and human beings. And at the heart of the African continent lies another volcano, one that may be more destructive than all the rest, Mount Nyiragongo. With the fastest moving lava in the world and 2 million people living in its shadows, when Nyiragongo erupts, it could be the worst natural disaster in history. And now, it is awakening. To forecast when Nyiragongo will erupt and save the lives of millions, volcanologists venture into the belly of the beast, searching for clues in the crater of the active volcano.
Lava is boiling, extremely violent.
For the next time Nyiragongo erupts, it could destroy the homes and lives of multitudes of people. Up next on Nova, Volcano Under the City. This fertile valley in Central Africa is one of the oldest inhabited places on Earth. It's dominated by a volcano soaring 2 miles high, Mount Nyiragongo. Ancient legends claim Nyiragongo is the place souls go after death, both heaven and hell. For years, the volcano smoldered peacefully in the distance. But then on January 17, 2002, Nyiragongo violently erupted.
As dawn broke over the eastern Congo today, the sound of fear filled the Rami city of Goma.
Nyiragongo spewed rivers of molten lava down its slopes at speeds up to 40 miles an hour. The sleeping city of 500,000 people was taken completely by surprise. Burning ash and lava ignited fires and destroyed everything in its path.
There is panic as frightened people scramble over the black lava crust, trying to escape, and many are getting hurt.
There were people who died trying to save their belongings. Everything was burning red. There was smoke everywhere. It was worse than war.
The 2002 eruption left over 100 dead, 120,000 homeless, and over 40% of the city destroyed. Now, Nyiragongo, the fire-breathing mountain, is reawakening. The only question is, when will it erupt again? In a race against time and nature, the UN dispatches a French volcanologist, Jacques Durieux. His mission? To collect evidence from the 2002 eruption and search for signs of new volcanic activity. From the city of Goma, he follows the blackened path of the 2002 lava flow, leading back to the volcano. As he flies above the rim of the crater, he sees an important clue. There's no lava visible near the top of the volcano. For some volcanoes, this could mean it's dormant, with no imminent threat of eruption. But in the case of Nyiragongo, it could mean danger lurks below the surface. There are two basic types of volcanic eruptions. Explosive volcanoes, like Mount St. Helens, blast enormous amounts of gas and ash from their tops. The lava erupts violently as tiny rock fragments that blast as high as 20 miles. And when it comes down, it scourges the earth in superheated clouds of ash and steam, called pyroclastic flows. The second type of eruption is effusive. Here in the Hawaiian volcanoes of Kilauea and Mauna Loa, lava is very fluid and flows like rivers. It erupts from anywhere it can, over the top of the crater or through cracks along the volcano's base. Nyiragongo is effusive and is distinguished by an extensive network of cracks, or fissures. These fissures radiate like spindly spokes out from the base of the crater, both on the surface and underground. They can fill with magma and erupt anywhere along the fracture zone. Duria inspects the web of fissures through a thermal camera. The heat along the fissures makes them appear white hot. Even more frightening, he discovers Nyiragongo's deadly web of fissures extends beneath the city of Goma. On the trail of the deadly lava, Duria inspects the site of a buried village at the edge of a banana plantation, halfway between the volcano and the city. When Nyiragongo erupted in 2002, the people living here felt they were safe because the volcano was miles away. But then, the fissures filled with lava beneath their feet.
Some people were able to escape and to run from the lava, but the old one and a sick man were not able to run like that. They have been caught by the lava and they've been killed by the lava flow.
Magma that reaches the Earth's surface is called lava. It flows as hot streams, and Nyiragongo's is especially lethal, the fastest on Earth. Its unique composition produces a molten fluid that's been clocked at speeds up to 60 miles an hour. Not even the fastest human in the world could outrun it.
Here the lava was liquid, like water. It was a huge surge of lava flowing down the slope, and it arrived in a banana plantation. Banana trees are just a very soft plant. If you push it, it just collapsed.
But these plants did not collapse. The lava surged around them, and when it cooled, what was left were hollow molds of banana trees. In the year 79, the eruption of Mount Vesuvius near Pompeii also created molds, but these were of humans, captured as hollow forms at their moments of death. Vesuvius killed 3,300, but if Nyiragongo erupts without warning, as many as 2 million could be killed. But how do you forecast the eruption of a volcano? Volcanologists search for clues in 3 basic ways.
The first way is seismology, by looking at the distribution of earthquakes beneath a volcano.
The second is land deformation.
We look at whether the volcano is inflating or deflating by looking at very small movements in the flanks of the volcano.
And the third way is by analyzing the chemistry of the gases in magma.
We can look at the composition of the gases to understand whether magma is at shallow or deep levels.
These are the clues Durieux seeks as he continues his quest at Goma's Volcano Observatory. Here, Congolese researchers closely monitor a seismograph, an instrument that amplifies and records vibrations from tremors caused by the movement of magma beneath the Earth.
As magma moves up beneath the volcano, you physically have to displace the rocks that are around it. So the breaking of rocks creates these earthquakes. And as magma moves up, you'll tend to get more and more earthquakes at shallower and shallower depths. And that's a sign that a volcano is likely to erupt.
The seismic activity Durieux sees today is disturbing.
The new recordings we have got today is showing that there are many, many shocks.
Normally, Durieux would compare today's seismic readings with those from 2002, looking for patterns to predict a future eruption. But Goma's observatory, in an area racked by civil war, had been looted just prior to the last eruption, so the previous seismic record is incomplete.
La voilà.
Durieux is joined by Italian volcanologists Dario Tedesco and Orlando Vaselli. They turn to satellite images to measure land deformation.
A signal is sent from the satellite down to the volcano, and the distance from the satellite to the volcano can be measured very accurately. If over time we see changes in that distance, we understand that the volcano is inflating or rising on its flanks.
And now, if we go to the image taken yesterday...
These color-coded satellite photos show the area around Nyiragongo rising and falling, as if the volcano is breathing in and out. Durieux and his team suspect this land deformation, combined with the increased seismic activity, may be the result of deadly magma in the fissures. But the amount of magma within the volcano is a secret, hidden in Nyiragongo's gas emissions.
We have a huge plume extending towards the west-northwest of the volcano, with a huge quantity of gases.
The gases are an intimate part of the magma that is generated deep in the earth, and as that magma comes towards the surface of the earth, the pressure on that magma is reduced. And as the pressure is reduced, gases then escape from the magma.
The greater the amount of gas being released, the greater the amount of magma being produced.
For what we have known in the past, never we have had such a big amount of gases. Never.
The satellite identifies the gas as sulfur dioxide, SO2, the primary cause of acid rain. And Nyiragongo is producing more than any place in the world, up to 50,000 tons per day. That's more than the amount produced by all power plants, factories, and cars in the United States. And the high concentration of SO2 is another clue for forecasting the next eruption.
If we see high concentrations of carbon dioxide, that's often a reflection that we have magma at greater depth. But when we start to see large amounts of sulfur dioxide being released from a volcano, it's an indication that we have magma at very, very close to the surface and potentially erupting in a matter of days or weeks.
Durieux and his team are breaking new ground at Nyiragongo by gathering scientific data in order to forecast the next eruption. But they are uncovering some very alarming clues. The increased seismic activity is the result of tremors caused by magma moving beneath the Earth. The enormous emission of sulfur gas is a clue that a huge quantity of magma is near the surface. And the thermal data shows Nyiragongo's fracture zone is extending toward the city. With no lava visible in the crater, and the satellite showing deformation of the land around the volcano, it could mean that magma is moving into the fissures.
Such a stock of magma under the volcano could trigger an eruption anytime and anywhere.
This emerging picture could be the worst possible scenario. Nyiragongo may be storing this huge amount of magma throughout its deadly web of fissures. Even worse than the devastation of 2002, Nyiragongo, with the fastest flowing lava in the world, now threatens to erupt right beneath the city of Goma. To discover just how imminent the threat might be, Tedesco, Vesely, and a researcher from the Goma Volcano Observatory gathered gas samples all along Nyiragongo's web of fissures.
If you have a spatial set of samples, in other words, one that's collected in the crater, and then a series of samples that are collected outside the crater, that gives you a way of understanding the plumbing system in the volcano. It gives you a sense of how open that fissure system is between the crater and the outer flank.
At this thermal spring, they measure temperature and chemical composition.
Chemical composition, isotopic composition give us exactly which is the source of these gases.
The team checks this fissure with a device called a sniffer. All volcanic gas contains a mixture of water, carbon dioxide, and sulfur dioxide, but their ratio can be an important clue.
If we were to find a high temperature gas with similar water, CO2, sulfur gas ratios on the outer flank of the volcano, it would give us an indication that perhaps magma is very close to the surface.
But the buildup of magma in Nyiragongo's fissures is not the only threat to the people of Goma. Here they are reading a high percentage of carbon dioxide, an invisible gas we all breathe out. It's harmless in small amounts, but in large quantities it can be lethal. 15% will kill you, and this fissure reads over 60%. Alarmed by these extremely high levels, Tedesco and Vesely head to Lake Kivu. If that much CO2 is leaking from the volcano through the fissures and into the water, Lake Kivu, the picture of calm today, could be a ticking time bomb. It's a lethal phenomenon called Lake Overturn, and it happened in Cameroon, West Africa, in 1986. Throughout villages along the lake, dead cattle and corpses lay scattered. There was no sign of panic. 1,700 people appeared to have just dropped dead. At first, investigators were baffled. Then they discovered the smoking gun. Lake Nyos sits inside the crater of a dormant volcano. But for hundreds of years, springs beneath the volcano continued to feed carbon dioxide gas into the bottom of the lake. A landslide into the lake triggered the gas to bubble up to the surface. When the inside of the crater was full, a cloud of CO2 spilled over the rim, crept down into the valley, silently spread through villages, suffocating every living being. Tedesco and Vesely fear that if fissures from Nyiragongo are feeding CO2 into Lake Kivu, a lake 2,000 times the size of Lake Nyos, with 2 million people living on its shores, a catastrophe much worse could happen here.
The quantity of gas that will be released from depth to surface will be enormous. A very huge clouds of gas, both carbon dioxide and methane.
To test for the levels of these volcanic gases in the lake, they submerge this canister 1,300 feet. Then they drop this small weight along the rope. When it reaches the canister, it activates a closing mechanism. They need to analyze samples from the deepest part of the lake, since water containing CO2 is heavier and therefore stays at the bottom. They find the level of carbon dioxide dangerously high and in a delicate balance.
In case of huge injection from the bottom because of a volcanic eruption, for example, of volcanic gases, the equilibrium will change and the gas will go toward the surface.
A sudden eruption of lava or infusion of CO2 from underground fissures could cause Lake Kivu to release its toxic gas, resulting in a massive loss of life. As Durieux and his team drive the route of the main lava flow from the 2002 eruption, they find the situation in the city even more dangerous. People are building homes right on top of the lava's deadly path.
What is surprising is how fast the people are rebuilding on the lava flow.
Yeah.
And coming back to live on the lava flow.
They are not afraid of they don't have another place to go. I believe they don't really understand the danger that there is here.
The scientists have taken nearly every measurement available, but two critical pieces of the puzzle are missing. A gas sample from within the volcano's crater to compare with gas in Nyiragongo's fissures. If they're the same, it would be a sign that the volcano is actually under the city. And a sample of Nyiragongo's lava to help forecast when the volcano will erupt. To get these samples means climbing into the belly of the beast. Climbing into an active volcano is extremely risky, but if the team can give the people of Goma enough warning, they may be able to save millions of lives. Durieux prepares to trek into the volcano. This is not the first time Durieux has led an expedition into Mount Nyiragongo. He first came here in the 1960s and has been back often. Locally, he's known as the bearded man who comes from the volcano. He's been working with many of the same trusted porters for 25 years. For not only is an expedition into an active volcano naturally dangerous, in Goma, an area plagued by civil war, danger can also explode from politics and tribal rivalries. The team of scientists, climbing specialists, and 40 porters follow the black hardened path of the 2002 lava flow, actually passing one of the places that lava erupted from a fissure. Nyiragongo is in a chain of roughly 100 volcanoes that dot the region called the East African Rift. At one time, this region was the source of the Nile, but 2 billion years of eruptions transformed its headwaters into lakes. Today, Nyiragongo is one of only a few volcanoes still active in the region. As destructive as the 2002 eruption was, volcanologists know Nyiragongo is capable of much worse.
When we think about the risk, the hazard of this region, we have an eruption occurred 700 years ago that covered completely the whole region. So we have to think that the Nyiragongo might in the future, because of changing eruptive style, might again cover the whole region. And this will be a real catastrophe.
Finally, after a 6-hour ascent, the expedition approaches the rim of the volcano. It's here, at 11,400 feet, where the team sets up base camp. At last, Durieux gets his first look into the red glow of the molten lava, the fiery tip of a column of magma extending deep into the center of the Earth. The next morning, after a night spent literally clinging to the edge of the volcano, the team rendezvous beside the crater's edge to plan their descent. The crater is gigantic. At 2,600 feet deep, it's twice the height of the Empire State Building. Inside, there are two main plateaus, the first ridge and the lava plain. At the very bottom is the pit of molten lava. Duria decides to scout ahead with expert climber Jacques Barthélemy.
Je fais la longueur suivante, hein?
Ok, vas-y.
Nyiragongo's walls and rock face are extremely fragile. Foot and handholds are abundant, but finding places that will not give way is difficult. The crater is constantly shaken by microquakes, loosening its walls. Duria and Barthélemy descend 1,000 feet to reach the first ridge. It's strewn with massive boulders that have fallen from above and vents emitting skin-burning sulfur gas.
Là, c'est joli, hein? Ouais, ouais.
They proceed cautiously across the fragile surface to the edge, where they get a better look at the lava, which is curiously low. On his first expedition into the volcano, the lava was nearly as high as the first ridge. Nyiragongo boasts a lava lake that can fill within weeks and drain within minutes. When full, it's the largest in the world, holding enough to bury Manhattan in 15 feet of lava. Over the years, the lava solidified around the edge, leaving the ring-shaped plateau Duria sees below. By now, the core of Duria's team has arrived on the first ridge with extra climbing equipment. To get the lava sample, they'll have to make an additional 600-foot vertical descent.
Doucement, 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 doucement.
It's a lot further down to climb, in a crater with volatile lava that could quickly rise.
Et je devrais arriver d'ici 20 mètres à peu près.
Ok, très bien.
The plain is fractured by 1,000-foot crevices, on ground that at any moment can crumble beneath his feet.
Voilà. Juste en dessous.
There is very little lava at the bottom of the volcano, but what is there poses a great threat. It's extremely violent, spewing 200 feet in the air.
So that's really fantastic, because the gases are exiting at very high speed, at very high pressure. We have big flames, huge volume of gases, extremely violent.
By the end of the day, the core team reaches the lava plain. But as they set up a second camp, the weather turns against them. Temperatures drop near freezing, and winds whip up to 60 miles an hour. The team knows that tomorrow, getting close enough to Nyiragongo's lava pit to retrieve the lava sample will be extremely dangerous. The next morning, the team sets off to collect volcanic gas samples rising from the lava plain. These gases are given off by hot magma under the surface. Tedesco and Vesely will compare them with samples they collected in Goma and along Nyiragongo's fracture zone. Durieux sets up his thermal camera. White and orange indicate the hottest areas, the ones that are closest to magma. The information from the thermal camera tells Tedesco and Vaselli which fumarole or vent will yield the best gas sample.
So we are looking for a specific place where the temperature is good, high enough. At the same time, the depth is very little, so we can insert our tube, sampling tube inside.
To get a pure sample, the fumarole must be just the right depth and narrow enough to not allow atmospheric and volcanic gases to mix. Finally, they locate the perfect spot.
Drop by drop, we are able to get the water, the steam basically condensated with a lot of acidic gases.
The gas, condensed into liquid, drips into the sample bottle. It appears Tedesco and Vaselli may have gotten the first pure volcanic gas sample ever obtained at Nyiragongo. Suddenly, disaster strikes.
There are main collapses of the walls. It's a fault.
The walls of the crater are collapsing.
The fault is crossing the crater and making huge collapses of the platform.
And the plain beneath their feet is falling into the lava lake below.
Huge amount of blocks, old lava, were falling into the lava lake.
Massive cracks are appearing and spewing scalding gases dangerously close to the men. Rock slides throw toxic ash into the air. A windstorm whips through the crater. Conditions are life-threatening. And the lava pit is growing more violent.
Projections are very high, but between 15 and 16 meters high. The sizes of the sputters is between 2 and 5 meters. So it's so violent that we cannot reach the point.
Nyiragongo seems to be fighting back. The team cannot climb down low enough to retrieve a lava sample. They're going to have to retreat. Nyiragongo has yielded one prize to the scientists, a pure sample of volcanic gas to help them understand how far the volcano extends under the city. But if they're going to retrieve the lava sample, they'll have to devise another way and hope Nyiragongo will give them a second chance. Back in Goma, the team finds more signs that the volcano is awakening. Durieux visits one of the seismic monitoring outposts built after the 2002 eruption. Here on the seismograph, there's evidence of the landslide he and the team experienced inside the volcano. Aftershocks continue, and the people living in this village can literally feel the danger in the air.
They are having problems with the rain and with the volcanic ashes because when it rains, the ashes fall all over their bodies and it hurts them.
One villager has been collecting rainwater, and Tedesco does a chemical analysis.
Very acid water, very rich in chlorine, fluorine, nitrate, and sulfate.
Nyiragongo's volcanic gas is producing skin-burning acid rain and poisoning the village's drinking water. Even worse, the team is called in to investigate reports of some mysterious deaths at a nearby school. Tedesco and Vaselli test gas from a fissure just off the playground. They find 24% carbon dioxide, well over the lethal limit.
The children were playing games, hide and seek, and they went over there and they suddenly died. Then people came with tree branches and hauled them away with a rope. They took him away to bury them. It was very sad.
It appears even as Nyiragongo slumbers, it is already claiming lives. The children fell victim to an ancient killer, a Mazuku, or evil wind. Mazukus are pockets of odorless volcanic CO2, and for miles around, hide in what appear to be harmless clusters of grass. In Swahili, Durieux warns the villagers how the deadly gas can kill. He ignites a safety flare and tosses it into the Mazuku. The smoke sits on top of the CO2, which has displaced all the oxygen. Anyone who goes beneath the smoke suffocates. Small children are usually the victims. It happened to this woman's child. Here is the spot where a neighbor found her daughter. She had sent the child to get some sugar, but she never came back. Later, she learned the child had walked through the Mazuku and died. Tremors and aftershocks, acid rain and polluted drinking water, and now children killed by gas emissions. The threats to the 2 million people living in the shadow of the volcano are intensifying every day. But to forecast when Nyiragongo will erupt, Durieux and his team still need one crucial piece of data: the holy grail of volcanology, a sample of lava from the volcano's fiery pit.
Even if you only had one opportunity to sample a volcano, that tells you a lot about where it came from, how deep it came from, how long it took to get to the surface, whether it's been sitting at a shallow level for a long period of time, or whether it's traveled a long way in a very fast, potentially explosive manner. It gives you an important forecasting tool as to what might happen next.
Armed with a plan on how to retrieve the lava sample, Durieux and his team pack up their equipment and head back up the mountain. When the men arrive at the summit, Nyiragongo's pit of lava, 2,600 feet below, is more violent than ever. Normally, volcanologists can retrieve a lava sample by walking right up to the source. In Hawaii, they have been retrieving samples weekly for the last 20 years. There, a volcanologist will dip an iron hammer or rod directly into the lava. It solidifies on the iron, and they quickly pull the sample out. But for Durieux and his team, that's impossible. They'll have to retrieve their lava sample from 1,000 feet above the lava pit. Their plan is to extend a rope across the pit, guide a pulley to the center, and lower an iron hammer into the lava. To do it, they'll need to pull the rope by hand around the perimeter of the lava plain. But the plain is ringed with massive pillars, some as high as 200 feet, and the fragile ground can collapse beneath them at any moment. Durieux has risked his life before to retrieve a lava sample, a critical piece of evidence to forecast an eruption. But this may be the most dangerous situation he has ever faced. After several hundred feet, the task becomes more and more difficult. Durya moves carefully around the crater, which at this level measures a stunning 2,000 feet across, more than 6 football fields. The rope snags on the rocks of hardened lava below, exactly what they feared. One misstep could cause a landslide. They improvise, using a pole to elevate the rope over the columns of hardened lava. The mission to retrieve the sample is in jeopardy. With gas emissions increasing, their vision is obscured. Then, one member of the team climbs onto a lava pillar to untangle the rope, but disappears into the fog. It's a tense moment as the men wait anxiously to see if he is safe and successful. Finally, the rope is free, and Durya and his team are able to stretch it across the crater.
Ok, vous pouvez redonner du mou doucement.
They secure the rope and attach an iron hammer with a chain. They drop the iron hammer off the edge of the lava plain.
Matériel de prélèvement qui tout doucement avance.
There are 1,000 feet between the cable and the surface of the lava. Clouds of volcanic gas make it difficult to see as the hammer descends to the lava. So Durya must rely on his instincts. If he lets the cable dip too low, the heat will melt it. He tries to retrieve the hammer, but the cable seems to be stuck. Lava pools have a quicksand effect and could have swallowed the iron hammer into its pit. The cable is freed up, and on the other side of the crater, the men are turned into human anchors with the rope cutting painfully into their bodies. Durya watches anxiously as the cable rises through the dense smoke. They've lost the iron hammer, but the lava has solidified onto the cable. The sample is extremely fragile, and if it strikes the surrounding walls, it can fall back down into the pit.
Stop, stop, stop! Quand on va remonter, ça va arracher. Jacques, du mou mètre par mètre, tout doucement. Tout doucement, Jacques. Tout doucement, encore. Attention, laisse-moi passer. Laissez-moi descendre, bordel! Non, non, continue. Eh ben les copains, on n'a pas bossé pour rien, hein? Viens voir.
Finally, the attempt to retrieve a lava sample is a success.
Voilà.
Durya and his team risk their lives to get these precious pieces of lava, now cooled and hardened. But now, they must unlock their secrets if they are to save the lives of the people of Goma from the volcano that threatens their city. At the University of Florence, Tedesco brings the lava samples to one of his colleagues, rock and mineral expert Alba Santo. Santo prepares to study the lava samples under the microscope. The gas samples they gathered earlier are being analyzed in the lab. Gas from Nyiragongo's network of fissures, some from right under Goma, will be compared to gas from the crater.
The two main gases that are erupted during a volcanic eruption are carbon dioxide and sulfur dioxide. The very sensitive ratio between these two gases often tells us how close the magma is getting to the surface.
The analysis reveals the gas sample taken from the crater was over 1,000 degrees Fahrenheit with extremely high levels of sulfur dioxide. The gas from the fractures under the city contains barely a trace of sulfur dioxide and is less than 200 degrees. Less sulfur dioxide and lower temperature in the fractures leads to a surprising conclusion.
We think that these fractures are very well sealed because we detect a steady decrease of temperature and gas emissions.
This suggests that magma is not threatening to erupt from fractures beneath the city. Yet all other evidence, seismic activity, land deformation, and the huge quantities of gas emissions, all indicate Nyiragongo is producing enormous amounts of magma. If not in the fissures, and not in the crater, then where could it be? Perhaps the new lava sample can solve the mystery. In Alba Santo's lab, she cuts the lava into thin sections and looks at them under a microscope. What she sees is the petrography, or history of the magma.
We can obtain from a petrographic observation what happened during the rise of magma to the surface.
By observing the size, shape, and composition of the minerals in the lava sample, Santo can determine clues to the origins of the magma. When she looks at Durieux's sample, she discovers two important clues. The lava's color and composition, a high concentration of iron and magnesium, tells her the magma formed at an extremely deep level, perhaps 50 miles or more beneath the earth. And it is stored in a magma chamber about 6 to 8 miles below the volcano. But when she examines the lava's microscopic structure, she's amazed to find no crystal formation at all, only gas bubbles, something she's never seen before.
This means that magma rises very fast from the source, and it doesn't have time for minerals to crystallize. So this lava is very fresh.
The pieces of the puzzle are falling into place. The huge quantity of gas with high temperature and high concentration of sulfur dioxide, and magma from a deep chamber rising so quickly it doesn't have time to crystallize.
We often say that there are two things that are relate to how explosive an eruption will be, and it's related to how fast the magma is coming to the surface and how much of the gas is released on its way to the surface. For Nyiragongo, these are two suggestions that the system is very active and potentially could move towards volcanic crisis in the near future.
The lava and gas samples, along with all the seismic and satellite data, paint a whole new picture of Nyiragongo, one perhaps more frightening than ever. Nyiragongo is storing vast quantities of magma that could reach the Earth's surface in minutes. And even though the volcano's fissures are sealed, any new seismic activity could open the fractures, infusing magma into the fissures, which now extend under the city of Goma and into Lake Kivu. The fastest flowing lava in the world could flood the city within minutes, and any lava, landslide, or volcanic gas entering Lake Kivu could trigger lethal lake overturn, suffocating everyone on shore in one giant mazuku. And it could happen at any time. Jacques Durieux returns to Goma. He's working with his Congolese colleagues to educate the people of the imminent dangers and to continue to monitor the volcano's activity. But to forecast precisely when Nyiragongo will erupt, Durieux and the Congolese will need more data over longer periods of time. For as valuable as this set of seismic, satellite, gas and lava samples is, it's just a single frame in a moving picture.
We may find that in 50 years or 100 years, we're able to compare samples collected in the future with the samples that Durieux and Jacques and others are collecting today, and find out that they give us really valuable information about the course of growth of that volcano.
But what does that mean for the people of Goma today? Some are heeding the warning and moving. Others are rebuilding their homes right on the path of the deadly lava flow. With more than 2 million people living in the shadow of the volcano, constant observation is necessary. For when it erupts, a new name could be added to the most deadly disasters in human history: Nyiragongo.
On NOVA's website, explore deadly volcanoes around the world. Go behind the scenes with the filmmaker of Volcano Under the City and more. Find it on pbs.org. To order this show or any other NOVA program for $19.95 plus shipping and handling, call WGBH Boston Video at 1-800-255-9424.
Could mean danger lurks below the surface. There are two basic types of volcanic eruptions. Explosive volcanoes, like Mount St. Helens, blast enormous amounts of gas and ash from their tops. The lava erupts violently as tiny rock fragments that blast as high as 20 miles. And when it comes down, it scourges the earth in superheated clouds of ash and steam called pyroclastic flows. The second type of eruption is effusive. Here in the Hawaiian volcanoes of Kilauea and Mauna Loa, lava is very fluid and flows like rivers. It erupts from anywhere it can, over the top of the crater or through cracks along the volcano's base. And over 40% of the city destroyed. Now, Nyiragongo, the fire-breathing mountain, is reawakening. The only question is, when will it erupt again? In a race against time and nature, the UN dispatches a French volcanologist, Jacques Durieux. His mission, to collect evidence from the 2002 eruption and search for signs of new volcanic activity. From the city of Goma, he follows the blackened path of the 2002 lava flow, leading back to the volcano. As he flies above the rim of the crater, he sees an important clue. There's no lava visible near the top of the volcano. For some volcanoes, this could mean it's dormant, with no imminent threat of eruption. But in the case of Nyiragongo, it's awakening. To forecast when Nyiragongo will erupt and save the lives of millions, volcanologists venture into the belly of the beast, searching for clues in the crater of the active volcano.
Lava is boiling, extremely violent.
For the next time Nyiragongo erupts, it could destroy the homes and lives of multitudes of people. Up next on Nova, Volcano Under the City. This fertile valley in Central Africa is one of the oldest inhabited places on Earth. It's dominated by a volcano soaring 2 miles high, Mount Nyiragongo. Ancient legends claim Nyiragongo is the place souls go after death, both heaven and hell. For years, the volcano smoldered peacefully in the distance. But then on January 17, 2002, Nyiragongo violently erupted.
As dawn broke over the eastern Congo today, the sound of fear filled the very city of Goma.
Nyiragongo spewed rivers of molten lava down its slopes at speeds up to 40 miles an hour. The sleeping city of 500,000 people was taken completely by surprise. Burning ash and lava ignited fires and destroyed everything in its path.
There is panic as frightened people scramble over the black lava crust, trying to escape, and many are getting hurt.
There were people who died trying to save their belongings. Everything was burning red. There was smoke everywhere. It was worse than war.
The 2002 eruption left over 100 dead, 120,000 homeless. Krakatoa, an exploding island, creating 120-foot tsunamis, drowning its victims for hundreds of miles. Vesuvius, incinerating the inhabitants of Pompeii with superheated clouds of ash and steam, entombing them in rock for 1,800 years. Mount St. Helens, obliterating everything in its path: trees, houses, and human beings. And at the heart of the African continent lies another volcano, one that may be more destructive than all the rest: Mount Nyiragongo. With the fastest moving lava in the world and 2 million people living in its shadows, when Nyiragongo erupts, it could be the worst natural disaster in history. And now, it is